Hello and welcome to a demonstration of the wave-type interactive illustration from the Science Primer blog. A link to the model can be found in the description below. This is a net logo model. Let me begin by providing an overview of the interface. It's interactive. These models typically need to be set up before they can be run, so there's usually a setup or reset button somewhere that needs to be selected first. In order to run, there's usually another button that says run. In this case, it says propagate wave. And in addition to these buttons, there are other ways to interact with the model, switches or on-off buttons that allow the user to vary model parameters and behavior. In the case of this model, we have one pull-down menu here that allows you to select different wave types and a number of on-off switches at the bottom. Another thing to keep in mind about these net logo models is that the speed at which they run is a function of the processor speed of the computer. So if you have a brand new computer, they may run very quickly. In order to adjust this, there's a slider that you can adjust the speed at which the model runs. So now let's begin. To begin, we'll select the Set Reset button. When this is done, a line of particles appear. These are the particles through which the wave will move when the model is run. In all cases, energy will be propagating from left to right across the screen. Particle motion will of course depend upon the type of wave we're visualizing. One particle in the middle, which I call the observer, is a little larger than the other, which will allow us to better visualize individual particle motion. So if we go ahead and begin, we'll select particle propagate wave, and the motion will begin. The wave type selector is on longitudinal, which means wave particle motion is parallel to the propagation of the energy. To see this better, we can set trace observer on, and now a line appears in the path of the observer molecule. If that is not enough, we can go ahead and say trace all. The model will begin again, and you can see the motion of all the individual molecules. Again, if you have a new fast computer, you may need to adjust the slider to allow better visualization. To see other wave types, simply select the wave types to the right here and set reset. The second option is a transverse wave. Energy will still be propagating from left to right, but now particle motion will be perpendicular to the direction of energy propagation. So if we begin this, let's go ahead and turn all the tracing off for now. You can see energy moving from left to right, and we can, same thing, visualize all or none of the motions. The final wave type is surface wave. These waves occur at interfaces, and so with this model, it's important to think about this as the top layer of some interface, say water below and air above, for example. Now if we watch this wave and we can move it, slow it down even a little bit, go ahead and turn the tracing on, you can see that again energy is moving from left to right, but in this case particle motion is circular. You can do trace all. It makes it difficult to see what's going on once all the traces are done, but it does illustrate very well how a bunch of particles undergoing circular motion can allow the propagation of energy. There's one final feature here, multiple layers, which I haven't discussed. This allows us to give the medium through which the particles are moving some depth. The additional calculations here may cause the model to slow down. Let's go ahead and start. We can do this with any of the models. We'll turn tracing off and go ahead and run a longitudinal model. This may slow down because of the extra calculations. You can go ahead and speed it up or set it wherever you want at the slider. And of course, we can trace all the molecules. We can look at transverse. Now the thing that's most interesting with this one, this allows us to illustrate one additional feature of surface waves. Again, we're at an interface where this is, say, water, and above at an air interface. If we go ahead and set this running, again we see the ability to energy propagating this way, all the molecules making circular motions. But what this illustrates is that as we move away from the interface, the motion of the particles diminishes. If the top layer of particles is the interface, as I said before, we can see that as we go further, there's less motion. When we turn the tracing on this, the diagram gets very busy, very difficult to see what's going on, but does reveal the decreasing orbit of the particles and layers further from the interface. And finally, with surface waves, you eventually reach a point below which there is no motion, which is why they're called surface waves. Along with reduction in particle motion with distance from the surface, the amount of energy that is propagated also decreases, again to where you reach a point where there is no energy propagation in a deep enough layer of water below the interface. That's the demonstration. Thank you for watching, and enjoy the illustration.